Like people are getting murdered or something. Come on, you stupid things. Sorry, guys. I've heard the talk got quite all my life. Must be tired. Come on. Come on. Always get rid of the sigma notation first. Rosie, have you figured out how to do that yet? 5. Wow, what? Okay, you sub in 1. You can see -1, which is, so this is all of these. You sub in 1, that is 2. You sub in 2, that is 5. You sub in 3, that is 8. So you sub in 1, 2, 3, right? And if you sub in 1, that is 5. If you sub in 2, that is 8. Remember, the coefficient is what they're going up in. Okay. And if you sub in there, that's 11. And then the last term will be 3n minus 1, 3n plus 2. So that's what the sigma notation expands to. We're good with that? Figure where you went wrong? What don't you understand? Don't have to write this next line. I'm about to write. That's what the question becomes, right? Without sigma notation. We'll okay with that. You could, but yeah, to be fine. I'm going to do that now. Okay, so that's just getting rid of the sigma notation. Now we can start the deduction part of the question. So we're going to first prove it's true for n is equal to 1. So if and this other one? If and? Wow. Wow. And the one. remind me, Eva and Vladimir to do registration. Make mistake. But for what? The first term, the term one. In is one. This means the first term, yeah. Okay. You could put it in there and get two, basically the with term one. Look. What's going on in those brains? You're doing in physics at the moment. It's not making stuff. So that's doing about physics. Okay. Me too. That's anything more. Come on, let's keep going. Keep going. Please always write that K is a natural number. Right, so go write down your assumption in math if you haven't yet done that. Good. Effie. Okay. Some factorizing is better. Okay. Hi. You know, Donald Trump. Right, so we're going to have to use that assumption at some point. Do you agree? Sometimes it's worth trying. Hang on. Okay, so that's what we're going to prove, right? Hey guys, you will understand this is the term in position K. This is the term in position K plus 1. Because this whole thing is saying term 1 plus term 2 plus term K will always be equal to that. Okay, so we're going up to now term K plus 1, right? So I think, okay, my gut feeling is that factorizing is going to be quicker than multiplying out. Multiplying out with a right. I mean, it's
not
not
too bad.
Okay.
It just doesn't look nice.
it's tedious. But let me see if I can do it by factorizing. Okay. It's quite satisfying when you get there. No, solve mode. Solve mode, yeah.
Wait, why? Is that what you
No, it's not bad, but probably take, I don't know.
trying to do it in the space today? And it's my calculator out. I've become like.
I'm addicted to solve.
I love literally so bad, so bad. I'm told it's not work for me.
But solve only works for one within one solution, eh? Use something called Newton's method. Okay. And sometimes it can give you the wrong solution if there's more than one method. But with exponents, there'll always be only one solution. So solve should always work for exponents and it should always work for logs because they're one-to-one functions. Basically, if something's a one-to-one function, solve should work. Yeah. It will work, but sometimes we had a very weird thing happen in my class the other day. We half of us, we all did exactly the same thing on your calculator. I still don't know what's happened there. And half of us got the right answer and half of us didn't. That's just weird. Okay. Right, so there is our, so we've got to force that into the sum, right? Okay. So if I say, so that equal to 3k cubed okay, so I get that. I got plus, no, I think you're all going to have to times up. Okay. So let me just see. Okay, so this we're going to have to times up, so that's going to be plus 9k squared plus 15 plus 21k plus 10. Okay. Alison, did you get it in the end? Did you get it in the end? But 3k cubed plus 15k squared. Am I right? 3k cubed plus 15k squared plus 22k plus 10. So that's the left-hand side. Okay. Right. The right-hand side. We're trying to prove this, right? So the right-hand side, I think factorizing might help.
Oh.
So the right-hand side, well, what can you take out as a common factor from the right-hand side? Just might speed things up a little bit. K plus 1, right? So go take out k plus 1. Take out a common factor of k plus 1. I think it will speed up the process. Done. Okay, right-hand side. I'm in the set because there's a spider nesting in our house and she said I must get rid of it. Oh man, it's a nice little nest. It's not going to do anything. No. I once lived with a rain spider in my room for like when I was young. For like 2 months. And we just hung out. Never happened in my house. Dale and Amber, they leave the house. I have to go catch it. And I don't just take it outside. I have to walk like to the other end of the complex. And they make sure I walk to the other end of the complex and dump it there. Some poor house up there is getting a lot of spiders. Where I've never actually told Mam this. And I don't know whether it was a dream to this day or whether it was real. That I saw her when I was asleep and I looked over and there was a rain spider on her head. Now, I don't know whether it was the next day I woke up and thought, was that a dream or was that real?
That happened to me. We were driving. We rented a car. We were like 5, and I was sleeping with my head on the door, and a spider crawled out of my head, like a massive spider, like this big. And we pulled over on the side of the road, and we had to get this guy to help us get it out of me and my own get back in the car. So I was like trying so I washed my hands, so I was drying them in my towel, and then I felt something. No, there was a huge red spider in my towel.
That's what happened to Dale the other day. She got the dish plonked down, dried the dishes, whatever, and she grabbed it. And honestly, she went at, I think it was the speed of light, from the kitchen to outside the house. And I knew, okay, red spider. Right, so right-hand side, take out K plus 1. What we left with? Okay, we factorize this, guys, so we can save you a bit of time. Okay, big cow, what we're going to have? Sorry. I mean it in the nicest possible way. Yeah. 6K plus 1, yeah. So, good. Okay. So now, it just might speed it up a little bit. I'll get K plus 1. Carry on for me. 3K squared. That's 6K, eh? Right. Which will then be 3K, not much quicker probably. 3K cubed plus 12K squared plus 10K. Yay. Okay. Therefore, for the proof, the actual proof, no, the actual proof probably like we're 7 or 8, and the steps are with another 4 or 5. Okay, truth, therefore, true. Yeah. Yeah, not a problem. Okay, we got there. Where's our high level was I always keep a glass of water next to my bed. And I ended up that for some reason, something's not right here. And I turned the light on, and there's a big part-time prawn spreading water. Your what? Part-time prawns. Part-time prawns terrify me. And they won't die. They refuse to die. This discontinuity and limits and that stuff we first did. And then also we're starting logs tomorrow. Continuation of logs, yeah. Just use something called log-based E, yeah. You're writing at 12. Oh, no. It's hectic. You got fun. And then some physics exams the last 2 years, like. Varsity was the thing where you can leave. It's like a 3-hour exam. You can leave within the first, anytime within the first 2 hours, I think it is, but you can't leave in the last half hour. And then that one physics exam probably like after an hour. Type switch is leave. But did you get it? Okay, everyone got the previous one, right? Apparently this one gets a bit ugly. Let's have a look. After this one, we'll have a break. Okay, use math in the next one. That's alternating signs. By the way, this is how you alternate signs always, guys. Okay, but if you ever have to do that for some reason, that if you're working with natural numbers, that causes whatever you work with to alternate signs. -1 to the one is -1 squared is 1, -1 cubed. Okay, so that makes the signs alternate. Okay. So, for n is equal to 1. What's the left-hand side even? Just the first term. Okay. Okay. -1 comes 2, which is -2 over 2, which is equal to -1. Right, so it's true for n is equal to 1. You speak any French students here? What little cow in French? Petit vache. Petit vache. Okay, let's go.
Also, the egg is the
Spell it for me again. B.
There's an E on the after
B. Petit.
E, yes, and then B-A-H-E. And then
Petit vache.
Jordan.
Petit vache. Okay. Petit vache. That's going to be you, Emma. Petit vache. And what's big cow? Grand. Oh, that sounds quite nice. Grand vache. Okay.
Even C after the T after the T.
Petit vache. Grand vache. Okay. Okay, right. We're going to try find ourselves now. They're not pigs. They're cows. Okay. Petit vache, grand vache. Okay, right. Okay, let's have a look at this because finally this gets ugly. Okay, right. So now, petit vache, grand vache. And try this, guys. Try it yourself first, otherwise it's a waste of time. Okay. Russians, come do this, please. I'm going to type this one. I'm going to give it. No. That's fine. Right, so there's the assumption. Right? Okay, we're all happy with after the assumption. Okay, right. Right, so then we're going to go try prove. Something installed, left-hand side, equal to choice. Yeah, but the -1 to the k does the alternating for you. So then, -4 -9 -k, k plus k. So that whole thing, because I'm subbing k plus 1, so k plus 1. There's our substitute. Hey, right, let's have a look. Wait. Okay, did you guys get it, by the way? Alison? Okay. No. Okay, -1 to the k, that's k plus 1. I've got 2. Yeah. That's fine. Okay, what I've done, guys, is I've taken this is our assumption. You with me? Okay, and this became that. Okay. All right. Okay. I know you finished, but you can do the next one then. Right. Okay. Everyone okay up to there? Right. Now, look at the right-hand side. First of all, what's it all over? It's all over 2, right? So let's just get this all over 2. First of all. Actually, but I did see like these, and I realized like there's just about nobody who ungram these that I actually know. I'm getting so old. Right. Okay. Ancient. Right. I know who Beyonce. Okay, Beyonce. I know. Okay. Drake. I know. Some of them I've heard of, like who? Charlie X something like that. Okay, but I wouldn't know one of their songs if it walked into the room. Heard of her, but yes, I wouldn't know how she is. But no, wouldn't know one of their songs. Okay, right. All right, so now, okay, well, we could take out a common factor of k plus 1, and we could split up minus k plus 1 to -1 to the k times -1, right? Okay, so you could take, I mean, I might be wrong. Okay, is everyone happy up to there? Come on, just put an exponent on it. Okay, so you'd have to rewrite this as, I'm just going to take out k plus 1 in the meantime. Okay, so if I take out k plus 1 from the, take out k plus 1 from the top. And in this term, you'll be left with -1 to the k times k. In this term, hey, you choose. I don't think yet. Plus 2. Wait, shut up, you two. Okay, this one, eh? Okay, have I done that correctly? Okay, I've taken out a big factor here of k plus 1. And I'm left with -1 to the k times k. Okay, plus 2 times negative 1, I'm going to take that out now, negative 1 to the k times negative 1 times k plus 1. Because to understand that negative 1 to the k plus 1, I rewrote as negative 1 to the k times negative 1. Took out a common factor of k plus 1, you with me? I've taken out k plus 1, and so from that term you left with that. From this term you left with 2, and then I rewrote negative 1k plus 1 as negative k times negative 1, and you left with 1k plus 1. Okay, so now I can take out what? Negative 1 to the k, eh? So I keep looking at this side over here. I keep looking at the right hand. I keep glancing at this. Okay, because I want to try to get it. So I've got that k plus 1, which I want. So the whole thing's got to be factorized. You with me? Okay. So now we could take out negative 1 to the k. And I can take out? Taking out k plus 1 already. Okay. Right. So then I'm going to get negative 1 to the k times k plus 1. Okay, that's the factor. And I'm left with, to get back to the green term, I'm left with just k, right? And to get back to the red term, I've got plus 2 times negative 1 times k plus 1. You agree? Okay. So then, yeah, we're going to simplify that whole bracket, eh? So we simplify that bracket. Yeah. So here you're going to get k minus 2k. With me? That's minus, so k minus 2k is negative k. Minus 2k. Yeah, that's minus 2k plus k, which is negative k, am I right? That's, so then minus 2, eh? Okay, great, we're there. Okay, let me check it. Okay, good. Right. Everyone happy up to there? I've just simplified. Yeah, I've got it. That negative 1 was making me nervous. Okay, so that became that. Logic. Right. No, you will never be. You'll never be asked this, but you'll be able to. But you'll be able to speak math, and you'll have logical skills. Right. Okay. All right. So now, guys, to say, so if I look at this, just have these. Okay. If I look at this side over here, I've got negative 1 to the k plus 1, right? The moment it's negative 1 to the k. Okay, but and the signs inside that bracket are incorrect. So what's negative 1 to the k times negative 1? How do I multiply? Okay, it's negative 1 all to the k plus 1. Okay, so how does that help us? Well, if I keep looking at this side over here, okay, at the moment that's negative k minus 2, we don't want that to be there, right? Okay, so we're going to take out, skip our steps. You got negative 1 to the k plus 1. From this bracket, you can take out negative 1, and then you're left with k plus 2 over 2. This is a kind of nice grown-up sum. And then if I times these two things together, negative 1 to the k times negative 1 is negative 1 to the k plus 1, right? You won't get any harder than this. Okay. So I get negative 1 to the k plus 1 will certainly be near the end of the paper. 12. 12 marks near the end of the paper. Yeah. Equal to the right hand side.
Yeah.
You on a break? And then we'll pop back. It's not something up. It was 2 hours. I had it. Let me run. Oh, we will. I'm doing the register now. What? I don't know. It was a tough one, I have to admit. Yeah, but different questions become easier. I don't know. Leia, Rosemary, Alison, Eva, Sana, Zoe. Because that's what you like to be called. Finally, you filled it in at one stage. Last time, no. Okay, start off last one. Okay, right, we got
Yes, sir.
last Inga. 1, 2, 3, try. On your mark, get the gun. If you want to. French people, have you finished the sum?
Yeah.
All of you. I'm going to come and look. Power game? Bus and Grand Bosch. Hey, French people. It's done. Victor, what do you do? Oh, what? Frig, come on. Victor. Victor. B. No. Factorizing, I think it's going to be a lot quicker. Yeah. You factorize. I wouldn't times out, guys. You've got two terms there, and in those two terms, what's the common factor at the top? K plus 1, K plus 2. So I take out K plus 1, K plus 2 as the common factor. Yeah. I think just take Yeah, this is where factorizing is definitely quicker. I've got to get a common denominator. Those two terms, your common factor, this term and this term, common factor is k plus 1, k plus 2, right? If I take out k plus 1, k plus 2 to get back that brown term over there, I'm left with k. Get back to that green thing, I'm left with 3. You agree? So you're left with the right-hand side. And that, ladies and germs, oh, look at it. Well, hello, Kiara. Mating Kiara. Well, hello there. So someday a guy puts a gun to your head and says, do this by induction, and you can't, and you're going to think it's only on stage. You bet you go watch. And you're killing each other there. What is this now? Some kind of masochistic kind of thing. Well, this is more like torture. Bye then. Petit vache. Petit vache. Grand vache. I wish you luck getting through the rest of the day. It's going to be a long one, I can tell. Okay. You're making slots look very hectic at the moment. Okay. Good luck with physics. Continuity, limit. Oh.
No. Yeah.
Bye, guys. What? Super easy. No. Well, I'm preparing your notes.